Well, thank you so much for joining us here today with Key 3 Strategies for Writing in Math, presented by Triumph Learning. It's an honor to be with you. My name is Alex Kajitani. I'm the California Teacher of the Year, and I'm also known around the country as the Rappin Mathematician. And so super excited to get started with you today. And first thing I think you need to know about me really is that, I'm just like so many of you on the call. Most of my career I've been right here at Mission Middle School, which is located in Escondido, the city of Escondido, which is in northeast San Diego. And Mission's an absolutely wonderful place to work. Let me just do one thing here as seems that there we go. Here's a picture of me teaching in my classroom. Again, most of my career I've been at Mission. I've been a 7th and an 8th grade middle school math teacher, taught all sorts of levels, all types of students and things like that. And one of the things that I really have found over the years is that one of the real keys to successful teaching in mathematics is that in order for students to create deep meaning in math, what they really need to do is they need to be constantly thinking about it, talking about it, reading and writing about it, and sharing it. Whatever the content that we're covering in class, they need to be doing these 4 things: thinking about it, talking about it, reading and writing about it, and sharing it. Not necessarily in this order, and not necessarily all 4 of these, one after the other. But if you think about if you're on Facebook, think about the last Facebook post you wrote. You were somewhere doing something, and maybe something fun or cool happened, and so you thought about it, and you talked about it a little bit with the person you were with, and you thought to yourself, hey, I'm gonna post this, and so you wrote about it either on Facebook or Twitter or something like that, and then you shared it, right? And then for the next 15 minutes of your life, you became obsessed with, I wonder how many likes I'm gonna get, or I wonder if anybody's gonna share this, or I wonder if anybody's gonna comment on this, and you really started to think about whatever it was, that was being covered. And that's really the same thing that we want to do with students in math class. We want to get them the academic content, but we don't just want it to be us talking about it, them taking notes, and then taking a test. We really want them, again, to think about it, talk about it, read and write about it, and share it. And so today what we're really going to focus on is that part right there. How do you get students writing about math, and how do you get them to do it in a way that's real and relevant to the academic content that we're teaching, but also in a way that's fun and engaging for them? And so the first key strategy that I'm excited to share with you today is really that writing is math. We cannot separate the two. We can't say that someone can just do math without ever having to write about it, or that somebody can write in math class without ever having to mention any numbers or anything like this. They're inextricably linked. Writing is math. Let me give you, something to think about here. When you really think about what do effective writers do and what do effective math students do, there are some real similarities. For example, effective writers are constantly using descriptions to create mental imagery, and effective math students are using numbers constantly to create mental images, right? When we say things like, when we use terms like lengths or amounts, when we say something is 3 feet long, an effective math student is going to be able to picture what 3 feet is. Or when we say that it was the distance of a football field, an effective math student is going to be able to kind of picture how long that really is. Just like an effective writer is using descriptions to really create mental imagery. If a writer says, the big red ball rolled down the steep hill, that's creating mental imagery, and that's the same thing that we do in math. The second thing that effective writers do is that they're constantly using symbols to convey emotion and to break apart thoughts, right? We know that when there's a comma, that means pause. We know that when there's an exclamation mark, that means that there's excited emotion in a sentence. Similarly, effective math students are constantly using symbols and operations to guide them in how to proceed, right? Effective math students know that when they see an addition sign, the total amount is going to get, is going to increase, as long as we're not talking about use operations with negative numbers. Or they know that when they see a multiplication sign, that what exactly we're going to be doing. We're going to be multiplying. They know that when they see parentheses that we're going to be doing everything inside those parentheses, and for example an order of operations problem. So again, effective writers constantly using symbols to convey emotion and to break apart thoughts, and effective math students always using symbols and operations really to guide them in how to proceed. Third, effective writers, they're able to constantly edit and rewrite their work, right? An effective writer knows that the first time they write something, that's not necessarily their final product. And so they can go back, they can edit their work, they can ask for opinions, they can rewrite their work until it gets to the place that they really want it. Likewise, an effective math student is constantly persevering in correcting mistakes to find the solution, right? Effective math students know that you might not get the answer right on the first try. So you've got to go back, see where you might have messed up or done an operation incorrectly, and really persevering in correcting the mistakes to ultimately find the solution that you're looking for. So again, math is writing, and the similarities between effective writers and effective math students are really undeniable. And so as we look at the 8 standards, for example, for mathematical practice that the Common Core standards show us, what we're really looking at, we're looking at so many things, but when we really look at that number 3, the ability for students to construct viable arguments and critique the reasoning of others, that's when the ability to write in math class and to write about math and to use math in writing really comes into play in a very important way. Let me give you another example, right? Numbers without writing are just numbers. They don't have any context. They don't have any meaning to them. If I put 50% up, yeah, we as mathematicians or as math teachers, we know sort of what that means. But when we put it up with something like this, now we know exactly what it means in context. 50% is 50% until we put words around it. Then suddenly know we're about to save a lot of money. I have to say it. Again, looking at more numbers, we've got the numbers 18, we've got the numbers 109.5 and 3,200. Those numbers don't really mean anything until we actually put some writing around them. And then it looks something like this. 18 to 24-year-olds send or receive an average of 109.5 text messages per day. That works out to more than 3,200 messages per month. Again, the writing is math, and the math becomes meaningful when we put writing around it. I always cringe when I see somebody wearing this t-shirt. I actually just saw somebody wearing this t-shirt when I was in the airport the other day, coming back from doing a training with some math teachers. Another day has passed and I didn't use algebra once. And I always want to walk up to the person and say, you don't understand. You're using algebra every single day. In fact, you're probably using algebra right now and you don't even know it. And so I always, I always cringe when I see that shirt, because really, writing is math, and math is writing, and algebra and math are used in every single moment of our lives. So one of the things that I love about Triumph Learning's performance coach is they're constantly having students do writing, right? Even as with things like translate this numerical expression below into words in 3 different ways, right? We've got those symbols, but a student could write 24 divided by 6 minus 3. They're taking the symbols, putting it into words. They could have 3 less than the quotient of 24 and 6, or they could even have the quotient of 24 and 6 minus 3. And so, again, constantly having students take the math symbols and put them into writing, or translate the writing into math in order to really give it some context on so many different levels, whether it's translation, or arguing, using math to justify a solution, using writing to justify a math solution, that is, and so many different great ways. Again, I can't stress it enough, but really the first key strategy is understanding that writing is math. This is what my classroom used to look like, and this is what it looks like now, and that's because I've really started to implement the fact that in order to create deep meaning in math, students need to be thinking about the math, they need to be talking about the math, they need to be constantly reading and writing about the math, and then they need to be sharing it with each other. The second key strategy for writing in math is that vocabulary is vital. Vocabulary, vocabulary, vocabulary. Students who don't understand the vocabulary that we use in math class tend to not do as well as the students who do. And check this out. This is absolutely fascinating to me. The Thrive by 5 Washington study found that by the time they are 4 years old, children from professional families have heard about 32 million more words than children from families living in poverty. 4-year-olds from professional families have heard about 45 million words. Those living in poverty have heard just 13 million words. The difference is critical when children learn to read. You know, like I said earlier, I travel all over the country. I work with teachers, and I always ask teachers when I'm doing a training, what are the 2 things that you struggle with the most when teaching math? And most of the time, the teachers will always say one of 2 things. They'll either say the students don't know their times tables, or working with students who don't know their times tables, or they'll say word problems, right? And what I've come to find is that the problem with word problems is actually the words themselves, and that's why vocabulary is so very vital. Let me demonstrate this with what I like to call a minute mystery, right? This is just kind of a fun thing that I do with my students to show them that a lot of times they're the same words, but in math they have unique meanings. So let me try to stump you with this right here. Are you ready? Okay, here it is. See if you can solve this. A man is inside a cave when a huge boulder falls in front of the entrance, completely sealing him off from the outside world. He is completely surrounded by thick rock, and there is absolutely no entrance or exit, and all he has inside the cave is a small stick. How does he get out? Ooh, it's not a stick of dynamite. Let me let you think about that for just a few seconds here. All right, are you ready? Here's how he gets out of the cave. First, he breaks the stick into 2 halves. Next, he puts the 2 halves together to make a hole. And finally, he climbs out the hole. Ba-dum-bum. Thank you very much. I'll be here all night. But actually, when it comes to the importance of vocabulary in math, this mystery actually gets it right, right? There are words that are just different in math, and we need to make that very clear to our students. For example, hole, which we just saw, W-H-O-L-E, is much different than an H-O-L-E, like a hole in the ground. Sum, or the answer to an addition problem, versus S-O-M-E. If you take mean, right, or the average in math, versus mean, which means not nice in so many other aspects of life, or in math, negative means a number less than 0 versus negative in all of the other, in so many other parts of the, or in so many other aspects of school or life, negative means, you know, not nice or something that's bad, right? So in math, vocabulary is so vital because they're the same words, but they often have these unique meanings that the students need to learn the specific meanings in order to go forward with understanding the vocabulary and the math. So again, vocabulary, so very vital. Of course, there was the student who was told to name the quadrilateral, so of course he did. He named the one quadrilateral Bob, another Sam, another Tennyson, Kate, and Harry, right? Name the quadrilateral. And of course, there was a student who was told to find X, so he or she, of course, did, and just said, hey, here it is. Vocabulary is vital in math, and that's why that's the second key strategy to understanding writing, to get students writing in math. One of the amazing things that I love doing with my students, very effective, is the Freyer model. And you can just do an internet search for Freyer model, and you can find all sorts of different variations that teachers, some math teachers, some other teachers have made. But basically, a Freyer model looks like this, and in the middle, you're going to put a word that you really feel the students need to learn. I just picked one. I picked slope for the example for today. And so on the top left-hand corner, the students would write the definition. Now, really important, they need to write the definition in their own words, right? They need to write the definition in their own words, not just look it up and copy down something from the back of the math book or from the dictionary, something like that, but they need to write down the definition. On the top right-hand side, or so, for example, here's one that a student of mine had for a slope, they put slant up or down, good kid-friendly words, right? That's a good example there. And so top right, they've got facts or characteristics of slope. So a student might write something like a positive slope goes up from left to right, or a horizontal line has a slope of 0. There are so many different answers that somebody could put for facts or characteristics of slope. But the point here is that we're getting students writing about math. And they're writing about math at their level, right? This Freyer model is just a great example of something where we can provide differentiated instruction and learning for the students because they've got so many different things that they can put. Bottom left hand, examples. They could draw a skier going down the hill. They could write something like y equals mx plus b with the arrow going to the m, right? So many different examples of slope. If we stopped and had everybody fill one of these out, we might get 25 different answers. And that's great because what we're trying to do here is build vocabulary and get students writing. And then, of course, really important, non-examples of the word. The cool thing about non-examples is that even your lowest level student can come up with a non-example, which at least gets them thinking about what a slope is. So for a non-example, they could have 5 plus 5, or they could even have a llama or something like that. If a student wants to get silly, let them get a little bit silly. I actually had a student who wrote llama for slope once, and one of the other students said, actually, if you think about the hump on a llama, then there is a slope there. That's the exact kind of dialogue we want our students talking about. Again, they're talking about it, they're thinking about it, they're reading and writing about it, and they're sharing it. So again, I highly recommend the Freyer model as a way to get students writing in math and also building vocabulary. A lot of people ask me, well, how do I know which words to select when using a Freyer model? And so here are 3 really good guidelines for selecting words. What you want to do is, obviously you can't give students a list of 10 words, have them do a Freyer model for all 10 words, right? So what you want to do is you want to select really high impact vocabulary words that are 3 things. First, they're important to understand the reading, right? Whatever it is that you're studying, the unit, that they're going to be really important to understand the unit and the reading throughout the entire time. Also, number 2, they can't be words that can be easily figured out by surrounding context or root, right? We want to pick words that are uniquely important that the students probably couldn't figure out. They're going to need to get a little deeper with the Freyer model to really understand this word. And then third, they need to be words that are useful outside of that particular topic, right? We want to select vocabulary words that the students are then going to walk outside and see in their everyday lives. We want to, select vocabulary words that the students are going to be constantly relating to, not just in your class in that moment, but throughout their academic careers or throughout their lives. So again, 3 really great guidelines when selecting vocabulary words. The third key strategy for writing in math is that a little goes a long way, right? You don't have to have students constantly producing long essays and things like that. A little goes a long way. Marilyn Burns has a great quote that I love. She says that writing in math class isn't meant to produce a product suitable for publication, but rather to provide a way for students to reflect on their own learning and to explore, extend, and cement their ideas about the mathematics they study. As Marilyn Burns, I love that. So when we think about the 2 different types of writing in math class, really there's 2 kinds, right? There's writing within math class, and that's writing that's used to activate prior knowledge. It's writing that's used to deepen meaning within math. And this is where we really don't focus on spelling or grammar or punctuation. We just have the students write to ask us a question or to activate prior knowledge. And I'll just give you some sentence stems that'll get students doing this. Of course, what we ultimately want to move them to are writing across the content areas, where they're using math to explain a phenomenon in history or science, where they're replacing beliefs with mathematical evidence. So for example, instead of saying a horse is very heavy, what they might say is a horse can weigh between 300 and 600 pounds, right? They're taking their belief out and they're putting the actual mathematical evidence in. And then of course, when we're writing across the content areas, we want to insist on correct spelling and grammar and punctuation, things like that, because now they're producing something that other people are going to be reading. Again, great way is to activate prior knowledge, get students writing, or just use these simple sentence stems. Explain in your own words, blank. The most important thing about blank is what I know so far about blank, or when I think about blank, I also think about, and then they fill that in, right? Let me show you what this actually looks like if we were actually doing something. Let's say that I knew that I was going to be teaching a lesson on square numbers, right? So here's what the sentence stems might look like. A square number is, and the student might write a line or two about what they think a square number is. An example of a square number. A non-example of a square number. Again, always pay attention to those non-examples because those will give you really good information. And of course, what I know so far about square numbers, that allows the students to write as little or as much as they want. And if they don't know anything about square numbers, well, you know, they can still write that down. Again, it gets students writing, gets them active, gets them thinking about it. You know, here's an example of a Smarter Balanced released assessment item that, you know, that they show. Here it says a rectangle is 6 feet long and has a perimeter of 20 feet. What is the width of this rectangle? Explain how you solve this problem, right? No longer are students just doing the math. Now they're having to explain how they solve that problem. Again, writing is math, and now the two are absolutely inextricably linked. Again, with Triumph Learning's Performance Coach, one of the things I like is they're having students constantly write about math. Emma's plant grew a ½ inch in 1 day. Suppose the plant continues to grow at the same rate. How tall will it be in 5 weeks? There's a lot of math that the students are going to have to do in there, but more importantly, or I should say just as importantly, they're going to now have to justify their answer. And I love it when students have to justify their answer because they can get as simple or as complex as they want to get when justifying an answer. And really high-level students are going to justify in a very complex way. Lower-level students are going to justify in a more simple way. And all are important and all are really, really valuable and give us as teachers really good information. Math journals, a great way, you know, they can to get students writing. They're a great way to have a chronological record of learning experiences. If students write in their math journals every day or every week, by the end of the year, they've written a lot of stuff and they've got almost a yearbook of what they've been learning. They're a great tool to help students think more deeply and clearly. And they're also a fantastic tool to really help teachers assess student learning. And you can see right where your students are. When do we use math journals? When new material's been introduced, you can explain in your own words the meaning of the term blank. In times of confusion or disengagement, right? You teach a great lesson and you look at your students and you can tell on their faces, uh-oh, they didn't get everything I just taught, or they're a little bit confused. Stop, have them write down 2 questions that they have about what they're actually working on. And third, you know, to reflect or go deeper. You know, hey, go back and review your last 3 entries. Select one to revise or add to. They're a great way of showing students where they were and where they're going. And so, again, revising, editing, adding to entries, going deeper, just a great way of using math journals. So we'll start to close this out and be happy to take questions. But again, in order for students to create deep meaning in math, they really need to be doing 4 things. They need to think about it, they need to talk about it, they need to read and write about it, and they need to share it. And hopefully in future webinars, we can talk about how to get students talking about math, how to get them reading about math, how to really get them thinking and sharing about it. But today we've really focused on 3 key strategies for getting students writing in math class. I'll say it one more time. We've got, in order for students to create deep meaning in math, they need to think about it, talk about it, read and write about it, and share it. I hope you've enjoyed today's webinar. If you like what you've heard, I highly encourage you to check out my TED Talk, Making Math Cool. It's all my greatest hits in 14 minutes and 32 seconds, and that's available on my website at alexkajitani.com. Also, I would love to connect with you on Twitter. I'm at Alex Kajitani. And also, if you're looking for strategies that work, my book, Owning It, was recently named recommended reading by the U.S. Department of Education. That's available on Amazon or on my website also. And just want to gonna go ahead and skip that so that we can get to the questions. And thank you so much for joining us. Thank you so much for Triumph Learning for presenting this webinar. And I'm more than happy to take any and all questions right now. Feel free to stay on and ask away.
Okay, so Alex, we have a couple questions already, so I'll go ahead and read them out to you, and then you can answer. What would be a good research topic for high school students to practice writing about math in a research form?
Ooh, yeah, that's a really good question. So I don't have all of the information as to what you're asking me, but I would say if you can combine it with any of the other classes that the students are taking. For example, if they're talking about global warming or climate change in their science class, right? They could start researching climate change by the numbers and using the numbers in order to make the case as to, you know, any actions that we needed to take. If they're studying something in history class and they are looking at time, you know, combining it with looking at timelines or percentages of people or percentages of population growth, things like that. But anytime you can combine it with something else that they're doing in another class, that way they really start to see that, hey, wow, I'm using math in all of my classes. And there was another one that it was talking about eating, right, and food production would be an awesome one also, to really look at food production by the numbers and how much water is needed to produce certain foods and how much you know, profit is made, things like that. So really anything that the students are already studying is a great place to start. That's an awesome question. Thank you.
So this sounds more like a comment than a question, but I'll go ahead and read it. When we do the Freyer model, the definition is the formal and the facts are where you put it into your own words.
Yeah, I mean, I guess I think it really is up to the teacher. What I like to do is I like to have the students put the definition in their own words. And the reason why is because when they copy down a formal definition from the, you know, say back of the textbook, there's really no incentive or accountability for them to remember that definition. Then they could go and you know, copy it down. But I think that if they can define it in their own words, that's going to be something that's going to stick with them for much longer and on a much deeper level. Now, they may need to look up the definition in the back of the book or get a formal definition and then put it into their own words. And they may find that their own words are the actual definition. But again, if they can't explain it, if they can't explain it in their own words, I don't really think they know it that deeply. I remember, I think it was Einstein who said, if you can't explain something to a 10-year-old, you don't really know it yourself. And so I think the same sort of you know, guidance applies when we have students define things. We could have them put the, you know, the formal definition, but always way more powerful if they can explain it to themselves in their own words, because that's the knowledge that they're going to summon when they need to access it, whether it's on a test or in a job or just out in the world.
So this question came in different forms from a couple of people. What do you recommend for students with excessively low to no reading ability?
Mm-hmm. Yeah, that's a really good question. So with excessively low reading ability, and I think that you might be talking about, you know, reading word problems, which is a whole nother webinar in and of itself, which I've done a lot of work on. But there are some times when you might just need to take a word problem and rewrite it in very simple terms, right? Taking all of the extra parts out. You know, you might just need to take you know, you can really write a word problem at like 3 different levels, where you've got the word problem as it exists, you've got one that might be a little bit simpler, but then you've got one that's so basic and simple. And if I had a word problem that I could put up in front of all of us, I could show you. But really thinking about rewriting it so that a low-level reader could just really start to grasp it on their level. Another great idea that I've started doing is this is just for, well, this works for all students, but you take the word problem as it is and cut it up into different cut it up by sentence, right? So let's say the word problem consists of 4 sentences, right? You cut it up or you write it up on the board in sentence fragments, right? Or you separate the sentences basically and then cut them up. Let me rephrase that. You cut up the word problem into the separate sentences, and then you give the separate sentences all mixed up to the students, and their job is to put the sentences in the correct order. So what happens is the low-level reader student is just focusing on putting the sentences in order so that they make sense. They're not worried about the math, they're not worried about the numbers, they're just trying to put them in order so that they make sense. Then they've really focused on how that problem, what that problem sounds like, whether or not it makes sense. Then you can move them to actually dealing with all of the numbers. But that's a real quick, simple thing. If you don't feel like cutting up the word problem, take the 4 sentences, write a different sentence on each corner of the board, and see if you can have the students put the sentences in the correct order. Great way to just get them started with reading without worrying so much about whether or not they're going to get the math right. Great question.
So we're about at time. Doesn't look like we have a couple of questions. Alex, do you want to maybe answer one more?
Sure, yeah, let's do it.
Okay. So what prompt would you suggest to get students writing about dividing fractions by fractions?
Ooh, okay.
And we can always, if you'd like, Alex, you can say, I can send you the remaining questions, and you can have some time to think about it. We can send them out when we send out the recording of the webinar as well.
Yeah, that sounds good. So in terms of dividing fractions by fractions, I would separate the thoughts, right? So instead of having students write about, what did you say that it was? It was dividing, what was the exact wording on that? It was dividing fractions by fractions?
Yeah, so what prompts would you suggest to get students writing about dividing fractions by fractions?
Right, so I would not start by having them write about dividing fractions by fractions, right? I might say, what do I know about dividing fractions? Or what happens to a number when we divide it by a fraction, right? You might say something like, what I have students writing, what I already know about dividing fractions is, right? And so before you combine the two concepts, just have them start to write about and think about, what does it even mean to divide a fraction? All of us know, right? When we're dividing fractions, we change the division sign to multiplication, and then we flip this. We take the reciprocal of, the second fraction. But maybe having students look into, why does that work? As teachers, we've been teaching tricks all these years, and so sometimes the tricks have replaced the actual deeper mathematical knowledge. But again, I say pulling them apart and just having a student think about, what does it even mean to divide a fraction? That way, when they have to divide fractions by fractions, they've got a little bit more of a base of understanding. Not sure if I gave like a great answer on that. Obviously, it's something that is tough to answer, through a webinar. But again, pulling things apart and then just dealing with kind of one chunk at a time.
So if everybody's okay, then we got a couple more, but I'll go ahead and send them to you on the side, Alex, and maybe we'll send out the webinar and the certificate for attending by the end of the week, and maybe we'll also put a document that has the questions that kind of went unanswered.
Sounds great. Well, thank you so much, everybody. Want to be respectful of your time. Have an amazing teaching year, and feel free to contact me, like I said, through my website or through this webinar. And I'm here for you. You're not alone out there. We're all in this together, and happy teaching.
Thanks, Alex.
All right, bye, everybody.